Today we are going to talk about the insider-outsider model and hysteresis that causes unemployment. So as usual, we are going to start with a profit function, and then the firm chooses labor demand. So the productivity here is kind of stochastic, and if we sub that in and sub in the production function and take first order condition, and that gives us the labor demand. And if we assume that the initial labor demand is this, then we are going to get that by taking logs we get this function. And here is one assumption. So the insiders want to set employment such that in expectation the unemployment is going to be the same as previous period employment. So we take expectation of the log function and we set that equals to this, which is by definition, and then we try to solve for w, and afterwards we sub w back into the equation, and that gives us the result. That is the employment rate here is a random walk. And note that if we assume that the insiders are the entire labor force and that is fixed, then by substituting that into this result we are going to get this, and by substituting that into the log function we are going to get this final result. So it is like a white noise process. Then we have a more complicated problem about wage setting and efficiency wages. So this is the efficiency wage. So whenever w is larger than x, we are going to get this as the effort function, but 0 otherwise. So the process works at first like this. The firm sets the wage. So firm's problem is to maximize employment, and from that they have their optimal response to the efficiency wage, and they set employment. So if the firm sets the employment and also wages, so they can have a expectation of the wage setting mechanism, and then they take that into their account, so we substitute that in. So we then take first order condition to derive the labor demand, and we note that L is a function of W here. So in order to get a function without L, we substitute that back into the first order condition and take first order condition with respect to W. So an alternative way is to take first order condition of the profit function with respect to W and L. So it will give us the same outcome, which is the solo condition. That is, we maximize the effort per unit of wage. So what determines the slope of the labor demand function? It can be either upward sloping or downward sloping. So sorry about that. We can derive that by taking first order condition of this LW, and then we will get a result That is, we will have W is larger than 1 over 1 minus alpha beta x. If this condition is satisfied, then we will have L dash W is smaller than 0, which means the Labor-Demont curve is downward sloping as usual. So the second problem is that now we have that the union selects the wage. So the process works by the labor union knows the reaction function of the firm, which is LW, and the first stage the union sets wage and then the firm sets employment. So we solve this problem using backward induction, and then we substitute into the union's problem LW and take first order condition with respect to W, and then we will get a solution which is called Wn. And if we have that the Labor-Demont curve is downward sloping, then we will have that the employment rate here in presence of union will be lower, so the union causes more unemployment. And as usual, we have the condition satisfied for the Labor-Demont curve to be downward sloping. And if we take another look at the Solow condition, it says that when beta goes to 0, then W is equal to X, so there is no efficiency wage motive. That is, higher X does not induce more effort. But when beta goes to 1, then the equilibrium will go to infinity. So next we will have a bargaining situation where a weighted or geometric average of the two objective function is maximized. So again, we are going to insert the firm's optimal response into the problem, and we work with logs so that the problem will be easier. And then we take first order condition with respect to W, and we get a value WB, which is where B means both have wage setting power. So how do we interpret this result? Well, if we have lower alpha, then the profit will be higher by looking at this equation. That means there is more surplus. So the payoff to the to the party with more bargaining power will be higher. So the union extracts the surplus from higher wage. Therefore, if we take the derivative of Wn with respect to alpha, we can see that this will be negative, but when alpha goes to 1, then the firm has got constant returns to scale, so profit will be 0 and there is no surplus to be extracted. When gamma equals 1, we have the wage is now equal to WB equals to Wn, because now we will only have the union's objective function taken into account. When gamma equals 0, we have the other result characterized by the Solow condition. How does WB change with gamma? Well, we can see that it will be something positive, and it will be larger than the case when beta equals 0. So remember, beta equals 0 means there is no efficiency wage, so the union's power matter less, but still when we have decreasing returns to scale, there will be positive surplus, so union's power is still going to matter, so the derivative with respect to gamma is still going to be positive. And we can also discuss the special case of the result when gamma equal to 0 or equal to 1, and we can see that union power leads to more unemployment.